Jai Hind everyone. Today's lecture is based on transaction processing. So first of all, we need to understand what is the transaction. So transaction is nothing but the collection of operations that form a single logical unit of work. So it doesn't matter how many operations are there. If we want to consider a transaction, all the operation will be considered as a single logical unit. Fine. So the operation that make up a transaction typically consists of request to access existing data. It may have a modification of the existing data. If we want to add new data, if we want to delete existing data, or the combination of these requests. So if we want to perform a transaction, any of the request can be accessed during that, right? Now, as we know, transaction can have many operations, but the actions that can be executed by a transaction need to include read and write operations on the database. These are the major operations, as read and write operations are the major operations which can have some manipulation in the database directly. In addition to reading and writing, each transaction must specify as its final action. Either it may be committed, it means what? It may be successfully completed, or it may be aborted also sometime due to some of the failure, due to hardware failure, due to software failure, whatever. So sometimes it may be completed successfully, or sometime it may be aborted or terminated due to any of the abrupt reason. Right. Now we can take an example of the transaction. Let's suppose we want to transfer fund from account A to account B. So how I will write the transaction in a log? So we will write the transaction. We'll start from the read operation. First of all, we need to read the account A, and as we want to transfer $50 from account A to account B, so what we will write here? We are deducting $50 from account A, and then we are writing A. It means what? If this account A is having initially if it is having $1,000, then after deduction of $50, it will be $950. Right. Now the next step is to read account B. So first of all, what is the initial value of that particular account that will be readed? After that, $50 which we have deducted from account A, now we need to add in this. Fine. So this is added by this operation, and then we will have the write operation. So this write operation will actually write the exact value, added value. So initially, if this account B is having $1,000, now it will have $1,050. So this is how one transaction can be done or executed. Now we will see what are the requirements for the transaction, what are the required property for the transactions. So if we have seen this transaction where we are transferring $50 from account A to account B. Now what will happen if this transaction fail after this third step and before this sixth step? So these operations will not be executed that time. So we'll lose some information that will lead to the inconsistent database. And why this failure? It may happen sometime due to some software or hardware failure that some of the transaction operations will not be conducted. But what will be the result in that case? It will lead to the inconsistent database state. Now, what will happen if these two operations are not done? So, what will happen? We'll check after this. Account A will have $950, but here account B is not readed, account updation is not done, so what will be written? No, nothing, new value will be written, right? So this is the requirement. Basically, system should ensure that the updates of a partially executed transaction are not reflected in the database, right? So this is the atomicity requirement. If that particular transaction is not following the atomicity requirement, that will lead to the inconsistent database state. Now the next property, what is required for the transaction? Durability requirement, right? Once the user has been notified that the transaction has completed, the updates to the database by the transaction must persist if there are hardware and software failure. So if there is a failure, then also that particular transaction should have that final updated value. So this is what the requirement of the transaction. So this is known as durability requirement of transaction. We will be able to recover that particular consistent state after the failure also. This is what the durability requirement of a transaction. Now another requirement is the consistency requirement, right? So what is the consistency requirement? Here we can see that here if account A is deducted $50, so if it is initially is having $1,000, then after deduction it is having $950. Then that value will be written in account A, so updated value will be written here. Then account B will be readed if it is also 1000. So after this operation it will this 1050. So the final value written for the B is the 1050. So what we can see here, the sum of A and B is unchanged by the execution of the transaction. So this is what the consistent result. Both the accounts, if we are taking sum of those before this operation, this is 2000. After operation, this is again 2000. This is what the consistency of both the accounts statements, right? So in general, consistency requirement includes during the transaction execution of the database may be temporarily inconsistent. So if we consider the if we consider this transaction after step 3, so what at this time we can see that account A is having 950 and account B, when we are reading this, it is 1000. So this is what a temporary inconsistency. It is allowed, but after the completion, when the transaction completes successfully, the database must be consistent. This is what the requirement of the transaction. This is known as consistency requirement. Now, what is the other requirement? Other requirement is the isolation. If step 3 and 6, if between step 3 and 6, transaction T2 is executed, right, and it is allowed to access the partially updated database. T2 accessed partially updated database. It will see an inconsistent database, right? So here we can see $950 here, and this is having $1000. So it will read 950 in account A, it will read 1000 in account B. So if we are adding both, what we will get 1950, whereas it should be 2000, right? So if we are having interleaved transactions, if we are having two transactions simultaneously executed and the operations are interleaved, then some inconsistency may be there sometimes. So what is the requirement for a transaction? Transaction can be ensured by running serially. So isolation can be ensured by running transactions serially, because inconsistency may be there when we are running two transactions simultaneously, but we cannot do so. Why? Because executing the multiple transactions concurrently has significant benefits. So we need to get that benefit. We cannot run all the transactions serially. It is very time consuming. So in real scenario, we need to maintain that concurrency through concurrency control module. So what we have studied, there are four desirable properties of a transaction known as acid properties. Acid properties: A for atomicity, C for consistency, I for isolation, and D for durability. So we have understood each and every transaction properties properly. Again, we'll have a look on that. Right. So what do you mean by atomicity? Either all of the operations that make up a transaction should execute, or none of them should occur. None or whole. If operations are executing in a transaction, it should be executed as a whole. If operations are not executed properly, some failure is there, so all should be reverted back. So this is the responsibility of a transaction management component of the DBMS to ensure atomicity, right? Consistency is another requirement of the transaction. Now, what do you mean by consistency? If all the operation of a transaction are executed completely, the database should be transformed from one consistent state to another. It is the responsibility of the application programmer who code the transactions so that consistency is maintained. So, acid property is there. Four desirable property of a transaction may important, and first property, who is responsible to manage this property? Atomicity, transaction management component. Listen carefully. And the another property is the consistency. Who is responsible for it? Who is responsible to maintain the consistency? Programmer who code the transactions so that consistency is maintained. Now the next property is what? Isolation. Now each transaction appears to run in isolation with other concurrently running transaction. Although we are running the transaction in concurrently, but it should be appear as we are running in the isolation. So the concurrently running transaction should not interfere with each other. Who is responsible to maintain this isolation? So it is the responsibility of the concurrency control component of the DBMS to ensure concurrent execution of transactions without interference from each other. So who is responsible to maintain this property? That is known as isolation, concurrency control component of the DBMS, right? So this is very important. We need to understand the acid property, as well as we need to know about the responsibility to maintain the responsibility about that particular property. Who is responsible to maintain that particular property? It is very important. Now the last property is the durability. Once a transaction is completed successfully, the changes may be made by the transaction persist in the database. Even if the system fails, we will be able to recover that. It is the durability requirement. So who is the responsible to ensure this durability? Recovery component of the DBMS will ensure to have this durability, right? Okay. Now come on the state of the transaction. We have understood what is a transaction, and we have understood the properties of the transaction. Now these are the state in which any transaction can have. Okay. So during its execution, a transaction passes through these phases. Transaction can be in active state, transaction can be partially committed state, transaction can be committed state, failed state, or aborted state, right? So this is the figure basically. So how first of all we need to understand what do you mean by active state, what do you mean by partially committed state, failed state, committed state, and aborted. Right. So come on the next slide, then we'll come again on that figure. Right. What do you mean by this active state? So the transaction entered into the active state on its commencement. So when transactions start executing, it will be in the active state. So what do you mean by active state? When transactions start executing, we can say that transaction is in the active state. Right. What do you mean by partially committed state? At the end of the transaction, it enters into the partially committed state. It means what? Transaction executed its final operation. Right. It means what? Transaction executed its final operation, but the changes due to the transaction are still in the memory. It means what? It is not written to the database. This state is known as partially committed state. It means all the operation of that particular transaction has been done, but still in the memory, not returned to the database. That state is known as the partially committed state. Meanwhile, any kind of hardware failure may prevent the data to return to the database. It may happen sometime. That's why we are saying this is the partially committed state. So before updating the database on the disk, the DBMS first write the details of the updation made by the transaction to the log file. Right. The log file is written to the disk so that the system can use the log file to reconstruct the updates when system restart after recovery from the failure. So do you understand the partially committed state? Okay. So the next state is the committed state. Now, after updation, all the updations are returned to the log file. The data is updated in the database and the transaction is set to enter the committed state. Okay. So once transaction has covered all the operation, executed all the operation, and all the operations are returned to the log file. Right. And data is updated in the database. So this state is known as committed state. Once the transaction is committed, its effect cannot be undone. The next state is the failed state. If the normal execution of the transaction cannot proceed any longer, it means what? Some system failure. Means some failure has been occurred in the system. So the failed transaction cannot be proceed further. So this is known as the failed state. Now come on that figure. When system start, when a transaction starts its execution, it will be in the active state. Now that transaction can be failed sometimes if there is any failure. So after active state, transaction can have failed state also. If it comes in the failed state, it should be aborted. Active transaction, if it is not failed, it means what? It will come in this partially committed state. It means data is in the log file, not written on the database permanently, right? So partially committed transaction may be failed sometime if there is an error. Or what will happen to partially committed transaction? Two way. Either it may fail due to some error or it may be committed. So this is the connection between all the states of the transaction. So by this figure, you can show the connections between all the states of the transaction. Okay. Now, concurrent execution of the transaction. As we know, if we execute transactions serially, it will not be beneficial for us, because in that case, we will not be able to utilize resources in efficient manner. So what is the requirement? We need to execute transaction concurrently. But if we execute the transaction concurrently, there are many issues. Interleaved transaction may have some interference with each other and they may lead to the inconsistent result, as we have seen in the previous example. So if we execute the transaction serially, less problem will be there. If we execute the transactions concurrently, there are many problems during the execution. There may be. So we need to take care of this inconsistency at various modules or at the programmer side, right? So the transaction processing system allows concurrent execution of multiple transactions to improve the system performance. Why we are thinking about the concurrent execution of the transaction? To improve the system performance. This is the one of the major reason. In concurrent execution of transactions, two or more transactions are run in parallel, but within the system only one operation of any transaction to be executed at any point of time, right? So what will happen? We'll see that there are multiple transactions are running at the same time, but in the system only one operation of any transaction to be executed at a point of time, but it comes so frequently, so we cannot understand the we cannot see that fluctuations, or we will not be able to see that there are more than one or multiple transaction and executing concurrently. So this is what we need to create that isolation during concurrent execution of the transactions, right? So concurrent execution of the transaction is also known as interleaving of the transactions, right? Okay. So we can see the example of the interleaved execution of two transactions here. For the simplicity, we are taking very small examples. There are two transactions, T1 and T2. Some operations of T1 will be executed. After this, some operation of T2 will be executed. After this, some remaining operation of T1 will be executed. So this is what the interleaved execution of two transactions. As this T1 is executing on the data item A, and here T2 is executing on data item B, and again T1 is executing on data item C. So these are not creating problems, because every time when we are executing some operations, these are on the different data items. But what happen when these data items are same? If we execute T1 on A, if we execute T2 on A, and again we will execute the T1 on A, there may be some problems, right? So let's see how we can face the problem, where we can face the problem, in which situation we can face the problem. We need to understand that, right? So first of all, we need to understand what is the motivation behind concurrent transactions. So one is the improve the performance, right? So improve throughput and resource utilization is one of the major reason to have the concurrent transactions. While one transaction is waiting for the data to be read from the database, the CPU can process another transaction. So this is the better utilization or efficient utilization of the resources. Overlapping the CPU in input output activities reduces the amount of time to time the processors are idle and increase system throughput, right? So this is the better way to improve the throughput and the resource utilization, right? So this is the main motivation for the concurrent transaction. Another reason is to improve the response time and reduce the waiting time. Interleaved execution of a short transaction with a longer transaction usually allow the short transaction to complete earlier. In serial execution, a short transaction could get stuck behind the long transaction, leading to the unpredictable delays in response time. So such problems can be managed through the concurrent transaction execution. Right. Now, before going further to the that concurrent transaction, we need to understand the schedule. What do you mean by schedule? The chronological order in which instructions belonging to different transactions are executed in a system are called a schedule. It means what? A schedule can have more than one transaction. Some operations from transaction T1, some operation from transaction T2, some operation from transaction T3 may make a schedule. So schedule is nothing but the chronological order in which the instructions belonging to different or multiple transactions are executed in a system. That is known as a schedule. A schedule consists of a set of instructions, must consist of all the instructions in those transactions, prevent the order in which the transactions appear in the individual transactions, right? So let us consider two transactions T1 and T2 and the following orders of the execution of T1 and T2. What is the possibility here? What will be the possibility if we are executing serially? It means what? T2 executing after T1 or T1 executing after T2. If we want interleaved execution, that may be possible, right? So there are three possibilities: serial, and interleaved execution of T1 and T2. First example is T2 executing after T1. So all the instructions regarding T1 will be executed. After that, all the instructions regarding T2 will be executed. So what is this? This is what? Serial execution of transaction. This is what? A schedule. We will say it is a serial schedule. Now again possibility, T1 executing after T2. What is happening here? All the instructions related to T1 will be executed after all the instruction executed regarding T2. So this is what? A serial schedule in which all the instruction of T2 transaction will be executed before all the instructions of T1. So this is nothing but the serial schedule again. Now this is what? The interleaved execution of T1 and T2. It is concurrent schedule, or you can say interleaved schedule, right? So this is one schedule in which some instructions of T1 will be executed. After that, some instructions of the T2 will be executed. Again, some instructions of the T1 will be executed. After that, again, some instructions of the T2 will be executed. So this is what the interleaved execution of T1 and T2. So this is what the concurrent schedule, right? So two schedule, this are serial schedule, but the last one is not the serial schedule. So if we are having n transactions, there exists factorial and valid serial schedule. As here two transactions are there, so two serial schedule are there. If we are having n transaction, factorial and valid serial schedule should be possible. So schedule where the instruction of transaction T1 and T2 are interleaved are called the concurrent schedule, as I told you, right? So where we are having multiple transaction in interleaved state of execution, we will say concurrent schedule, right? So several execution sequences are possible in the concurrent schedule. So number of possible schedule is much larger than factorial n. So there are multiple concurrent schedule possible, right? So we will not figure out it, but it is much larger than that factorial n, right? Okay, so we can see here one schedule is there in which T1 and T2 two transactions are there, right? So initially we can see that account A and B are both, some of them are initial value in both the account are 1000, right? So some of them are 2000, right? So we can see here T1 and T2 are there. So if we read T1, so it is $1000, and after some deduction of $50, it will $950. If we execute the right operation, what will happen? That account will be account will be updated by $950, right? Then T2 will be executed read operation on account A. So what it will read? The updated value it will read. Now some calculation has been done and temp is calculated. That is what the 95, and then what we is this operation? We are deducting the temp from account A. So this is 855. Then if we want to write this, that will be written as 855, right? So in again T1 is reading this account B. What is the value of that? Initial value is 1000, as we have said. So here it is 1000. If we are adding 50, then it will 1050. If we are writing this, that has been written here on the database, right? So again transaction T2, it is reading account B, so it will read the updated value of account B. Now temp is added in it, so here value will be updated. If we are writing means we are permanently writing in the database. So if we are taking the sum of account A and B, it is what? The 2000. It means what? It is the consistent consistency is maintained. So the result is consistent basically, right? So it is preserving the value or sum of A and B, right? So here we can see the another example. Here also we are starting with the initial value 1000 each in account A and B, right? And after some operations we can see that here we are reading this A. So it is 1000, we are deducting $50, so it is becoming 950, and then account transaction T2 will executed read operation. So what it will read? It will read 1000. Why it is reading 1000? Because we have missed this right statement here, right? So we have missed this statement. That's why it is reading the previous value, not updated value, because we have not updated by giving this instruction. So it is reading the incorrect value, and then temp calculation has been done on the incorrect value, and then after that temp is reduced from the account A, so it comes 900, right? Then that 900 is written in account as a final value, right? Okay. Now transaction T2 reading this account B. So what it will read, as we have given the initial value 1000, it will read 1000. Now if we are writing A here, now what will be written? As this updation is there but not written, so this updation, that operation is missing here, that basically comes here, right? So what it will return? It will write 950. So the place of this operation is wrong. It should be here. Then all the operation will goes inconsistent. But here, due to this operation misplacing, all the statements become inconsistent. Now account A is writing this, reading this. This is what? 1000. Now after updation it is 1050. We have written this, it is 1050. Now temp is added in this one. We are writing this. Now if we add this, inconsistent result, we are getting inconsistent result. This is not acceptable at all. So we need to very careful where we are placing these operations, as the placement of this operation is creating a problem. So such type of problem should not be there during the execution of interleaved transactions, right? Now does we see that despite the correctness of the each individual transaction, if we see that particular example, we know each and every operation is perfect, but we are getting undesirable result, we are getting inconsistent result. So the placement of that particular operation is very important, where we are placing. So this is done by the programmer. Okay, so the interleaved operation should be done very careful. So serial execution simple, but interleaved or concurrent execution is very different, right? Difficult. So to serial execution of the above schedule are as follows. We can take this example. This is very simply we can get, because in this example T1 is executing all the instructions before T2 executing, and in which T2 is executing all the instructions before T1 is executing. So it is very simple. We can maintain the consistency very simply by serially executing. But if the control of the concurrent transactions left entire to the operating system, right, as it is the responsibility of the programmer, but if we left this to the operating system, we can get the inconsistent state that may create the problem, right? So the concurrency control component of the database should ensure that concurrency, right? Okay. So today we are leaving our class here, and in the next class we will continue further in the transaction processing. Thank you so much.